Hello and welcome to our latest edition of the ACHEMA Highlight Webcast. The webcast where we introduce some of the topics that shape and change the process industry to you in the run-up to ACHEMA 2024. And of course, we will cover them in much more depth during the event here in June in Frankfurt. Now, one of the mega trends in the process industry certainly is sustainability. And often in public discussions, in the media and politics, this is brought into the context of decarbonization. Of course, that doesn't work for chemical production. We need our carbon. But what we can do is open up more sustainable carbon sources, be it CO2, biomass, or waste. This is being discussed a lot, sometimes in the terms of something happening in the future, very visionary. But there are people who are actually doing it today on an industrial scale. And it's my pleasure to introduce today's expert to you, Michael Köpke. He is the Chief Innovation Officer at LanzaTech, a specialist in synthetic and computational biology. And Michael, great to have you here today.
Yes, great to join you. Welcome.
Now, Michael, as I just said, sometimes the perspective of using waste to produce chemicals is talked about, well, as if it was science fiction. You at LanzaTech have been doing it for quite a while on an industrial scale. So could you give us some insight? What are you using? What are you producing? How is it going?
Absolutely, and indeed, it's a reality today. So, for example, the shirt that I'm wearing is made from recycled carbon emissions. So the technology we've developed at LanzaTech is a carbon recycling technology. So what that means, we can capture and transform carbon into useful products. We're doing that by using CO2 fixing microbes. So in a simple terms, you can think about it like the fermentation of beer and wine, but instead of sugars and yeast, we're using these carbon oxide gases and those carbon fixing microbes. So we essentially sparge those gases to those microbes and doing that in huge bioreactors of up to 1 million liters. And the microbes eat those gases and convert them to useful products like ethanol, for example. Today we have 6 commercial plants. The latest we started in Europe, in Belgium, just a couple weeks ago. Together, those 6 commercial plants give us a capacity of producing about 300,000 megatons of products. At the same time, we can also abate 500,000 megatons of CO2 emissions as well. The gases we can use are quite diverse. So we can use, for example, industrial off-gases. Think about heavy industry. In our plant in Ghent, for example, we're co-located with the steel mill. So we use those, we capture those steel emission gases before they go out of the flue stack and feed them then to our bacteria. But we can also use, for example, any kind of solid waste, so whether it's biomass waste from agriculture or municipal solid waste or plastic waste streams that can be gasified into a synthesis gas, which our process can use. And ultimately, we can also use CO2 with more and more available sources of green hydrogen. Of the products, I think ethanol is our first product. But we've developed a whole suite of products we can make that ranges from fuels, including sustainable aviation fuels, to chemicals and materials. And today we work with a lot of brands, including on Adidas, H&M, Zara, Unilever, Nibel, just to name a few examples.
So sometimes the use of waste for the production of chemicals has been criticized as greenwashing. I understand now you go via the CO2. Are there any limits to the bio-waste streams you can use, or the waste streams in general?
In general, I would say it's really imperative we make use of waste carbon streams and get away from a linear technology towards a more circular economy. I think in my view, there's enough waste carbon above ground. So if we're able to use that, then I think that's the most effective way to get away from fossil carbon. So for our technology, I think we can really use kind of the carbon very efficiently. I think it's certainly true that we're not recycling nearly enough today. I think the recycling rates are not high enough. I think there's certainly key challenges, including having mixed material streams. And with traditional recycling, like mechanical recycling, you can only do that so many times. If you look at our technology, for example, in Japan, we have a semi-commercial unit that's next to a landfill. And it's essentially everything that's really non-recyclable, where everything's already been recycled, what can be recycled with today's technology, that remaining waste is turned into a gas that's currently used for making electricity. But of course, there's ways to make electricity without wasting carbon. So with our technology, we can use that gas stream and feed into our process. So if we do gasification on those mixed materials, and those can be very diverse, you can really turn all of the carbon fraction into a gas, and then that gas we can use. Importantly, I think the biology is able to handle chaotic input streams. So I think that's a huge advantage. So if you look at diverse feedstocks, I think that's really enabling this.
I suppose that's where the expertise in synthetic biology comes in handy to kind of tweak those microorganisms.
No, indeed. I think as a company, I think we started in 2005. So I think it's been a long journey. I think obviously scaling the process up in 15 years for first of its kind technology through multiple demonstrations from pilot and demo scale. But also I think when we started in 2005, there weren't any genetic tools available for these organisms, and we've developed this synthetic biology platform, and we can now modify and optimize the microbe using those tools, and really kind of for one, I think help to optimize dealing with these diverse feedstocks, but on the other hand also diversify our range of products we can make, and develop new products using the same technology. And biology allows you then to use the same plants as well to make something else by just changing the microbe that has a different software code in the end.
So very promising way of reusing waste streams. Now, our viewers might wonder, you are targeting chemicals like ethanol, which are rather price sensitive. You are selling them already. Is it because you get a kind of green premium, or are you already price competitive? Or do you expect to be soon?
No, I think we wanted certainly to make an impact. As I said, the technology already kind of abated several hundred thousand of tons of CO2 emissions. So I think we wanted to have a product where we can make an impact. Certainly, as you mentioned, I think ethanol has a low price point, but if we can make that work, I think we can also apply that to other chemicals. And really, I think what's enabling that is that we are able to tap into low-cost waste feedstocks as raw materials. So I think using that, I think we are competitive with other routes of bioethanol. But of course, I think if you look at the corn ethanol or petrochemical industry that has developed for decades and been optimized for decades, so I think that's something that I think we're just at the start. So certainly, I think there's supply chain aspects I think need to further integrate and develop. I think we're working on diversifying the products, of course. But there's also a huge demand, I think, for sustainable products, especially, I think, from, for example, the more textile industry. I think I mentioned also sustainable aviation fuel, where there's mandates. So I think certainly, I think that's markets where I think in particular can offer an opportunity and advantage with the sustainability.
Great. I think it sounds great, and it's certainly very important that we have companies and people who show that it's not visionary, it's actually happening. So thank you very much for being with us today, Michael, and giving us some insight in your processes and your products.
Thank you very much, and I'm very much looking forward to hear all the innovations at the ACHEMA, and very much looking forward to that.
And if you want to hear more about closing carbon cycles, about reusing water, about building biorefineries, or anything else you can imagine under the label Green Innovation, just schedule your visit at ACHEMA right now. We will have our ACHEMA Highlight Session on Green Innovation with Michael Köpke and other experts on Thursday, the 13th of June at 1 p.m. But of course, the Green Innovation stage runs throughout the whole week, and you can find much more in the Congress. And if you want to look for technology to build your own plant, just join the exhibition. There's literally everything at your fingertips. You can look at it, you can touch it, you can ask the experts, you can get all the information you need. So make sure to get your ticket now and see you at ACHEMA 2024.